Hello everyone. Today I will show how to control a stepper motor from Rust. I will be mostly going over the software side of things, but for now just to understand the hardware that I have this is the motor that will be using. The interesting bit is that it uses 12 volts, so I provided 12 volts separately. And the step angle is 1.8 degrees. If you just look at degrees, it's not that useful, especially since it has some error. But if you do the math, what this basically says is if you divide 360 by 1.8, it's 200. So this motor uses 200 steps for a full rotation. So if I'm controlling this motor, I have to advance it 200 times for it to do a full rotation along its axis. And I will not be controlling the motor directly. I will control it using a motor driver, in this case an A4988. And this is reasonably complex, like many pins, but in practice what I need to control is just a step. So whenever I tell the driver move forward, it will move forward a single unit, and all the rest I actually pulled directly and I did not control. If you want to look at the configuration of how to connect things, this is how it looks like. There are many good tutorials how to configure it, and there is a current limiter that you also have to set up. It's mostly hardware configuration. I won't go through that. I will mostly do the software. Some ideas of things that trip me up. The reset pin is floating, so if you use this driver, make sure you actually connect it to something. And in this case, I just connected reset and sleep, so this makes the driver always enabled. It uses more current, but since I'm on a breadboard, that shouldn't matter too much. So this is the setup. Let's quickly get started. And the first thing I will do is I will clone any Blinky example. I will use my M0 Blinky example, but anyone should do so. Let's start coding starting from Blinky. So what Blinky does is it goes through one of the GPIOs, which is connected to an LED, and it starts moving, toggling that GPIO on and off, so it just blinks. So if I do cargo run, at this point I should see that my device is blinking on and off. And I guess what I want to do with the motor is I want to move it, stepping it forward and backward. So instead of the LED, which is on GPIO C, I know that my control pin is on PB3. So I'll connect, I'll replace the code to everything says PB3. This is not an LED anymore. Let's say it's called motor. And motor is initialized. And I will not blink, I will just run it. So after this simple change, let's do cargo run. And you can see the motor moving very, very slowly. This is not that useful. I think it should be a bit more visual. So let's make it 10 times faster and cargo run as well again. And you can see the motor moving. Great. So we have a working motor. This was simple enough. But let's make something a little bit more useful out of it. So what I would like to do is build some sort of a motor driver or motor control. And in order to do this, let's make an actual module, A4988, and let's put stuff in it. And the first thing I would like to do is figure out some terminology, because I will need to name things, and I have different steps and different moving parts of the motor. So let's name things. Autocomplete is strange. Okay, so the first thing I would like to say is what happens when I'm moving. I'm delaying the time a little bit, and I'm moving in this case, I'm moving the pin up, then I'm moving the pin down, and so on. So let's call this a time tick. So each time I do a time tick, I have, this is the same as one time unit, and it's just a number. And the other thing is when I do a time unit, I will need to actually decide when I move the motor. So I will have to step in one direction. So let's say 1 over 200 degrees, which is my motor configuration. Let's say this is a turn step. And this is also just a number. Excellent. So I have my description of a motor, and now if I am looking at how my configuration currently works, is I have this toggle. So every time I have a time tick, I right now toggle the motor. So I will move up, then down, up and down, and so on. So what I would like to do is control a little bit the speed. So even though my time tick will be constant, I would like to vary the speed on which the motor runs. So I want to achieve something like this. So at some point in the first tick, I will say turn the pin high and then low. This will make the motor driver move a little bit, and then I will want to delay some period and then do the whole thing again. So in this case, the speed of the motor, when I have max speed, I will achieve the same thing as the toggle, and then I can go slower if I want to. In this case, let's say it takes me 4 time ticks for me to do a single step. So let's describe this in code. So if I want to have a motor, the thing that the motor has, it's first of all, it has to have some sort of a pin. So this pin will be the thing that I send either toggle high or toggle low. And then the next thing is I would like to figure out what my current configuration is. So what my goal is. So I will say pulse information. And in this case, I want to go high, which will take 1 tick. And then I will have to keep low for n ticks. Or maybe let's say high 1 tick, so low is n minus 1 ticks. So in total, I need n ticks for me to do a single step for the motor. And then the other thing is, while the motor is running, so I will have to have some sort of state, and the state will be, I could be idle, so the motor may not run anymore, or if it's running, I will have to have some configuration that says running for how many pulses. Excellent. So I have my motor configuration. So let's define a little bit some of the structures. I know that my turn steps and ticks are just numbers. So I'll do something like this. I will say turn steps is U32 and ticks is also a U32. So they are just numbers. After that, I will look at the pulse configuration, and the pulse configuration, I will say, if I look at my pulse state, I might be high. So this means it goes, right now I'm in the turn that moves the value to 1. And then I will have to wait until the next pulse happens, and I will have to wait some number of turns. For convenience, I will also want to have some way to not refer to .0 or directly. So I'll do an implementation of turn steps and ticks. And what this means is if I get a turn step, I can call count on it, and it will just give me the number itself. It just makes for more readable code. And if I am looking at the motor, I will have to have some sort of a state. So the motor could be, we said, idle and moving. Great. I have the definition of idle and moving. And additional for this is if it's in moving state, I will have to have information about how the motor is moving. So let's say I have state and the motor could be idle, and when it's moving, I want to know how many steps are left to move and how many ticks I make in order to move one single step. So this will allow me to define the motor. And I don't know what pin it will be. Like it will be on any pin. Like right now I use PB3, but maybe I will use another pin later on. So let's call this control pin. And let's define the structure. So the control will be the control pin, and then I'll have a pulse, which is a configuration of how I will run things, and then I will have a state, and the actual state of the motor. It doesn't know what output pin is, and I can include that from embedded hull, I think. So let's use embedded hull like this. And it doesn't know what embedded hull is because I don't have it in cargo toml, so I will figure out from cargo tree, and somewhere in here should be embedded hull. So I need embedded hull 027. See, this made the compiler happy. let's implement the motor. Let's see what we need to do with the motor. So the things that I would like to do is I will want to create a new object, and then I will want to have a start turning. Then on every tick, I want to step a single run one step or a tick. And then anything else, I guess I want to know when the motor is has finished running, so check if idle. Let's implement these methods. The first one will be new, which is easy enough. If I create a new object, it should be in idle state. So what I will do is, if you give me a control pin, I will create a new motor, and the motor, the pulse doesn't really matter because it's not used, but the idle state is important because this says that the motor is not moving. At this point, I can try to implement start turning. So let's do something like pub function start turning, which changes self, and I will want to know how many turn steps I need to turn, and how many ticks I should take for a single step. So let's say ticks. And let's see about the return. I would like this to error out in case the motor is not idle. So this means I can only start turning if the motor is idle. If the motor is already turning, then this should return an error. So I will return a result. It doesn't matter what the actual result. What I care is about the motor, like the error code. So let's call this a state error. And I did not yet define state error, so I have to describe it. So what kind of errors can I have? I have probably two kinds of errors. So one of them is if the motor is already turning, so it's not in idle state, this is an error. And the other one would be I need at least 2 ticks per step. So the fastest I can move is I can toggle high and then toggle back low. So this means that the minimum number of ticks per step is 2. So if somebody gives me a value that's smaller than that, I want to error out as well. So this is my start turning, and I will return OK right now to make the compiler happy. It doesn't know what the result is. I'll remove the result. Lots of unused variables, but I will fix that. So let's now go through the error checking first. The first check that we said is if the state is not idle, then we error out. So I will do that. The next test is are the steps count at least 2? Or else is ticks per step should be at least 2. You know what, actually we'll allow 1. Maybe 1 makes sense to be the smallest value, and then 2 will be a little bit slower, and so on. And then let's go to set up the motor itself. And what we will say is if I start turning, the motor has to be moving, and how many steps I need to do is the input argument, which is the turn steps, and then how many ticks I need to do per step or wait, it will be the step count minus 1. So this is the amount of wait. And if ticks per step is 1, I will not wait and I will just move immediately. And the starting setup will be that on the next tick, I will send a pulse to the motor, and the motor will start spinning. The other function that is very easy to implement is checking if it's idle. So the check if it's idle just returns, hey, is my state idle? And if yes, return true, otherwise return false. The next bit is actually doing a tick. Let's say I'll call this function tick. And this should also return a result. And the result would be, I would like to return my current moving state in case the caller is interested to it. And I have to return some sort of error. The only thing that this can fail is based on the control pin, whether my setting the pin to high or to low errors out. So I will use control pin error. Excellent. So the first thing is when I get a single tick is I have to get the current state and see what my next operation is. So let's match on self state. And one thing that it could be state idle. And if it's idle, we remain idle. This is simple enough. And then the other state that could be, we could be moving. So we could be moving with the following ticks and steps. And this is the complex part of the code. So if I am moving, I have to figure out in which kind of configuration I am. So I could be, right now, I may need to move towards high. I may need to move towards low. And if I move towards low, I may need to wait. So let's go in here, and I will have to match self pulse and do some operations here. And not only that, whenever I advance the pulse, my current pulse will change. So I will do self pulse is some sort of operation that changes the pulse. So the first possibility is that I am on the high pulse. So right now I just moved everything to high. So what I will do is I will set the pin back to low. And once the pin is back to low, I want to meet my new state to be a waiting state. So I have to return pulse, steps until pulse, and I will use ticks per step. This is how long I wait until the next high pulse. My next possibility is that I have exactly 0 steps until I move to high. So this means that I will need to set the control back to high. And return pulse high. Notice how here these will return errors, so I can do some error handling. The other bit that is if I have steps until pulse 0, I will move to high, but not if my turn already completed. So I have to check if the turn fully completed. So if I don't need to turn at all, then I will set my state to idle. Excellent. And if not, if I have steps until pulse is 0, I have to set my pulse to high, and I also have to decrease the amount of states, the amount of turns that I have to do, because my turn, I just started another turn. So I will change self.state, completed one more step. So let's say decrease the steps by 1, and I keep the same amount of ticks for a single step. This is the most complex bit, and I think it should be enough. And the other part would be if I still have steps until the next pulse for some count, and because I'm still waiting, I just decrease the count. Let's see what makes the compiler unhappy. Semicolon, set high. Okay. And I have to return some sort of result as well. So I say, okay, I am still moving. Great, I have my tick function. So at this point, in theory, I should be able to use this new motor driver instead of me directly controlling the pin. So let's say motor it's a new motor of my control pin. If I should rename this, so let's say this is control 10. It doesn't have to be mutable, and then motor, I think it's just tick. start turning, and I will use turn steps 200. This will be a full turn, and the ticks I will use 1. I think is the lowest value that I set up. So this means turn 1 full turn as fast as possible, and I need to use the result, and let's run it. And you can see it's running. It's still running very slow. So let's try to move it a little bit faster. So notice that it ran a full turn and then it stops, which is exactly what I wanted. So I achieved moving motor. What I don't like is at this point that I have to do this loop in my main program. What I would rather do is have this controlled by timers. So what I would like to do is have some sort of configuration for the hardware assisted timer, and I will do that for Cortex M0. It looks kind of like this. So it says get timer 3, and let's put a very high rate. I will put 100 kilohertz, and I will set it up so that this timer is triggered every time. And in order for me to set up the timer, I have to make sure that it's not a pending interrupt, and I will start a timer. This will start a tick timer, and the tick timer will invoke a method that is named timer 3. And I will have to add a motor code here. At this point, I will have the motor be controlled both by the main function and by the timer. So because these in theory can run concurrently, I will have to put these 1 as global variables, and 2 I will want to make sure that they are configured and controlled by mutexes. So I will implement something like this. I will want to use the ticks and turn steps globally, and I will want to create a motor timer which I can control. So I want to control this timer 3, and I want to control my motor 1 and my motor 2. And the way to look at it is, first of all, these things will only be set up after main runs a little bit, so I have to put everything as an option. They have to be modifiable, so I have to put them in the ref cell. So this is why you have a ref cell that contains an option. And the last thing will be, I want to be able to have mutual exclusive access to these, so both from main and from my timer. So this is why everything is wrapped inside the mutex. So we have a mutex of a reference cell of an option of my object, which in one case, one is a timer because I have to reset the timer, and the other one is an actual motor, and I know that my motor is on PB3. So these are messy declarations, and using these messy declarations, I will also want to access them and make main clean. So I will say function motor turn. So let's say global motor turn, and in this case I will want to give it some steps and some ticks per step. And the way I access this is I want to do free and interrupt free for me to be able to access the mutex. And as long as a mutex exists and I have a value, I want to be able to call the start turning method. I don't have a mutex included yet, so it's from Cortex M interrupt. So let's say mutex Cortex M interrupt. Don't use STD because that won't work. And the ref cell, I have to include that as well. It doesn't know what timer is. And it doesn't know what timer 3 is. I have to include every single one of these. Great, after fixing lots of imports, I have my global turn function. So the next bit that I want to do is not only turn, but I want to also check the idle state of the motor. So what I would like to do is know if my global motor is idle, and I implement something that's reasonably similar. It looks something like this. It says I grab the global motor, and if I have one, I just return is idle, otherwise I will say false. The import for interrupt is wrong, so let's use the correct one for the proc macro. And there is a conflict here in terms of importing interrupts several times. And because the interrupts, the same name is used all over the place, I will have to use interrupt free directly. I remove the doc comment, and now the code in theory should compile. So in my interrupt, what I want to do is call the global tick function. It will look something like this. So let's say first of all, I figure out if I can get the timer, and if I have the timer, I want to reset it. Otherwise, timer 3 will keep on being called all the time. And then the next part will be I want to get the motor, and if I have a motor, I will try to do one single tick on it. And at this point in my main loop, in theory, I don't need to do anything specifically. I can just wait for the turn to complete. So I will say cortex M wait for interrupt. I am not using delay anymore at all because everything is asynchronous, and because I don't use delay, I don't need the peripherals that allowed me access to a delay. The next bit is I was using motor directly, but instead of using motor directly, what I should do is I should set up the global variables and save these, the motor and the timer. So I'll go in here and I will say set up the global motor timer and the global motor 1. And this means motor right now it's unused, so I hope I'll get an error. Perfect. It says I cannot transfer it, which is correct. So instead of saying start moving here, I will say global start moving. So global motor turn, and there are the exact same arguments that I had before. And at this point, the motor doesn't have to be mutable because I move it somewhere else. At this point, if we try to run, I am running the timer at 100 kilohertz, which is actually a little bit too fast for the motor to turn. So let's figure out, I want to turn every, let's say, 1,000 ticks or something. Otherwise, the motor will just not respond. So you can see that this turns reasonably fast, and we could make it faster, let's say double the speed, if I can say I'm only turning the motor every 500 ticks. And after one turn, it finishes. So one idea would be, let's see how I can control this thing by using the is idle configuration. So in my loop, I will say if the global motor is idle, then I would like to turn it. Otherwise, let's wait for the interrupt. And in order for me to turn it, I don't want to turn it with the same speed every time. So let's make some mutable tick count, and I will say this is 500 ticks. And I would want to toggle it between a high and a low tick count. So let's say the high tick count would be 3 times the speed, and I want to always turn it within one full turn, and this is 200 steps. So I will do a global motor turn, and I will use the turn count, and the ticks will be tick count. And if the motor is found to be idle, I will switch the tick count. This will toggle, so because I do 1500 minus 500 will be 1000, and then 1500 minus 1000 will be 500, so that will do switch between 1000 and 500 back and forth. And then I will do the same turn starting. So what I expect at this point is that the motor will turn with one speed, and then it will double speed, and then it will turn again. So let's try it out. And you can see it rotates fast and then slow and fast and slow and back and forth. So this is how you can write some sort of A4988 driver, and I did not control the direction, but you can certainly add that, and you can add micro steps as well, so that the turn is smoother, and you can read documentation about those settings. I hope this was interesting or helpful, or both. Have a great day. Thanks.